Welcome to the future. Technologies and innovations that sculpt our industry.
This episode recorded live at the 2024 AHR Expo. Learn more about Johnson Controls at johnsoncontrols.com.
Good morning, everyone. I am here with Chris Forth from JCI. Chris, you want to take a moment and introduce yourself to everybody, what you do?
Yeah, Jason, Chris Forth, Johnson Controls. I've been in the industry 30 plus years, engineering, product management, and now full-time regulatory focus. So
you have multiple different layers in your company, different industrial, commercial, residential. You do a lot of different things, and you handle the government affairs side for all of those departments. Is that correct?
I share some of it. We do have a full-time dedicated government affairs team that spends a lot more time on the Hill and stuff, but I do a lot of, call it support work, specifically when it comes to refrigerants and the HVAC products, where I have some knowledge with my engineering background. So I do spend a lot of time in the DC area, but I also spend time in the state area in Canada sometimes as well, as you know.
Yep. Well, that's good. Today we're going to talk about refrigerants and specifically some of the next generation refrigerants and, excuse me, why we ended up with the refrigerants that we're transitioning to now. Why did we leave behind 410A or 404A or 134A? Why are we moving to these next generation refrigerants like R32, 454B, CO2, ammonia, propane? What was the catalyst that drove us to this point?
Yeah, Jason, a lot of it is policy at both the global level and at the domestic level, and you'll know many countries are there trying to address, the climate issues associated with these refrigerants, and those issues have led to policy changes. I think we've all heard of the Montreal Protocol.
Right.
That was the first global agreement to deal with what we call ozone depletion. Now that's evolved to global warming potential. And now there are laws in multiple countries, Europe, the U.S., Canada, and so forth, that are really mandating a transition, to lower GWP. We already went through this with ozone, right? And now we're addressing the GWP side of things.
Okay, so originally we were getting rid of refrigerants because they were, again, ozone depleting, and now we're phasing out specific refrigerants because of the global warming potential of those refrigerants.
Right.
So the legislation is not specifying you must use this refrigerant. They just give us a target, and then it's up to the industry to say, well, to meet this target, we can use this or this or this.
Yeah, to get specific, we'll talk to the U.S. here on the AIM Act. There's the bulk phase down. So the American Innovation and Manufacturing Act, it has three parts. There's bulk phase down. I should emphasize bulk virgin refrigerant phase down. And the little, giveaway here is that it doesn't include reclamation,
right? That's where our key is right there.
And then the second part of the AIM is what I think a lot of people understand is the technology, the equipment prohibitions. EPA calls those the technology transition. So air conditioning, a certain GWP level at a certain date, refrigeration, and even automotive and phones are in scope. And then the third part that is still pending, hasn't been finalized yet, is the refrigerant management. That has to do with the reclaim, recovery, Section 608, and that sort of thing.
And some possible training requirements as well. That's something that the EPA was looking into. I did hear at a few of the podcasts this week that Europe is actually transitioning to a required training model for these next generation refrigerants. That's something that may make its way over here as well.
Right. EPA is asking for comment on that right now. They've asked for it. The comments were actually due.
There was quite a few
December.
submitted. Yeah,
there were a lot of comments submitted on that. So I think something will be done ultimately. I don't know what. Certainly, if you look to other countries like Europe, they're moving that direction. And I think from a safety perspective, quality of work, having that training and licensing requirements is a good thing.
It is. I mean, if you look at, say, a chef or a hairstylist, they have to have certification, they have to have recertification. There's a lot of training that they have to do in order to be able to, and we're dealing with things that are a lot more dangerous, that put other people in harm's way. The training thing should just be a no-brainer at that point.
Right. Yeah, and we're dealing with some equipment, right, that is, it's commercial equipment, right? As far as commercial, it could be a residential piece of equipment, but it's got voltage, moving parts. So having that training, understanding how refrigerants behave, how to store them,
How to handle them, right?
how to handle them is all important.
So these next generation of refrigerants, these 2Ls, what is it specifically that we need people to know that perhaps we were working with 22 or 410 or 134,
right.
and now all of a sudden we're, let's say, 454B or R32. What's the big deal? I mean, what is it that's scaring people?
Yeah, let me first start out with what those 2L refrigerants, as you refer to, are not. They are not hydrocarbons.
Thank you so much. I needed to listen. If everybody could tell 10 other people what he just said, and then those 10 people tell 10 more people, I think we'll be okay.
Yeah, it's understandable with human nature. When you think of flammability, right, you think of something that would be, wildly flammable. But these 2Ls are not that at all. Right. They're very close to the current,
A1.
flammability A1. The A's, the toxicity. The 1, 2, 2L, 3 are the flammability. They're very close to the class 1 on flammability. And in fact, if you look at the ASHRAE 34 flammability that assigns those, I mean, they were so close, literally within a few degrees of being the same class. But unfortunately, they are not. But the thing they are not, again, I want to emphasize, they're not hydrocarbons, right? So things like static electricity won't set them off.
Your power tools, your DC power tools, those things.
Technicians don't have to wear, anti-static clothes or grounding devices. None of that because of these refrigerants. Nothing like that. These refrigerants have a very, high ignition energy requirement to ignite, much higher than, like, say, a propane, which static, something like.
Right. It's
On the magnitude,
millijoules, right?
Right, millijoules. So they're not that. And the other thing I'll point out is, the refrigerant like 32 and the blend component, because 454B is a blend that has 32, and another well-known refrigerant, R1234YF, they've been around for a long time.
Right, around us, right?
Right.
And now they're starting to come mainstream. We've had them in our cars. We've got A3s in our refrigerator at home.
For 10 years.
Right,
10
and
plus
so
years.
it's been on the periphery, but now it is about to come into the mainstream here with all of these different applications as well.
Exactly.
So the thing I'd point out is that we used to have a specific refrigerant, and it have all of these uses. And as we move forward, we're going to see a lot of application-specific. Okay, for this application, we're going to use this refrigerant. For this application, we'll use this refrigerant.
Right.
We're not going to see a one-size-fits-all solution for these units moving forward.
Correct. The EPA's got, it's called sector like AC, refrigeration, automotive, and they're going to become very, I'll call it custom. It would be great if there was one refrigerant that worked for everything.
Yes.
But as these GWP levels get lowered, we have to be very specific, and that EPA controls that with their SNAP listings.
Right.
And so the delineation of the refrigerants will be very different by some sectors. Now, some will be similar, right? But the big residential, light commercial products, the big volume most people used to, will be either R454B or R32.
You can see a lot of those systems here at the show
Yeah,
this week.
right.
There's a lot of manufacturers that have a 32 unit or a 454B unit here on display. Residential, commercial, light commercial, heavy commercial, a lot of that stuff.
Yeah, air-cooled. We've got air-cooled chillers, very large tonnages that use 454.
Even the components, we're seeing 290 compressors here, A3 compressors, 454B compressors, intrinsically safe components at a lot of the electric booths. So, I mean, this is not something that's new. This has been around for quite some time.
That's right.
It might be new to us
Right.
because we haven't seen it before, but it's the technology and it's been out for quite some time.
Yeah, I've encouraged people to go out and look. If you've got a window unit you might have bought a few years ago, even 10 years ago.
Yep.
We have one in a small space in one of our properties, and guess what? It's probably 10 years old. I don't know the exact date. It had R32 in it.
Yeah, so I want to say it was 2014 or 2015, something like that, where it was allowed for use and importation. R32 in spot coolers and window units and things like that, packaged, sealed systems. So R32 has been down this road before, just on the outside of the main line, but it is now coming in.
Right. And what we've had to do because of that different 2L designation is update all the building codes.
Yep, and that's what's taking quite some time. It's not we have a lot of different building codes to the U.S. Not all states use the same code. They may use variations of the same code, so it does take some time to get everybody on the same page when it comes to something like that.
Yeah, I've spent a lot of time, and with our trade org, the Air Conditioning, Heating, and Refrigeration Institute, they've been really, at the forefront of this. But they have members like us that step in certain
The
states.
Speakers Bureau, yeah. I've done a few presentations with them for code
Exactly.
officials and things, right. So people like Chris and I do go to other states and talk to code officials and things, say, listen, this is what's coming, this is what you can anticipate. You're going to have to update the building codes because pretty soon you're not going to be able to buy these units. And something that just recently published last year and is finalized this year is what you mentioned earlier, the technology transition rule. So what does
Right.
that do for us?
Yeah, that's the equipment prohibitions. And unfortunately, that rule was finalized back in late October of
Right.
last year. And it had a surprise for us. For split systems,
Right.
had to be installed by January 1st, 2025.
Right, so what do I do with everything that's in my warehouse?
Exactly. Now the original law that's now been amended
Right.
for this sector, the air conditioning sector, that covers residential and light commercial and heavy commercial. We thought we would get a year sell-through on indoor components.
In the
outdoor
proposed rule, it was there.
And that's what it was back in 2022. We
Right.
thought we would get that. Now, industry asked for a simple date of manufacture. We said, look, if it's manufactured before that prohibition date, shouldn't be any restrictions.
Right.
What EPA forecast they would do is we'll give you a year. What we got was zero.
Right.
We said the manufacturing date for a split for a new system had to be installed by 1/1/2025.
Right, and that's just not going to happen.
Yeah, but here was the nuance. The nuance was you could still replace
Components?
components like a condenser, outdoor or indoor coil air handler, in an existing system. And what the problem was with that date of install was that it would have stranded some equipment in
A
the
lot of
channel,
equipment, yes.
equipment, right? So we went back as an industry, and I was really proud of our industry. All the contractors, all the
Yep.
distributors, the OEMs came together, and even some outside groups, and asked EPA to quickly amend that law. So the law was final in October.
Right.
They amended it again really by Christmas,
Yeah,
which
it
is
was
unheard
amazing,
of.
right.
Right. So now we've got a year sell-through. You can put new systems together for splits for a year.
As long as it was manufactured prior to
Right.
2025.
Now, there is a little wrinkle.
Yeah.
EPA has been very diligent about saying we don't want to limit the useful life of someone's existing HFC
Right.
equipment. So we can still manufacture indoor coils and components after the
Indefinitely,
date.
right.
But if we manufacture some of those after the prohibition date, in this case 1/1/2025, they have to be marked for service use only.
Right, as a component.
And one of those for service use only components, indoor outdoor, cannot be put together in a new system with a component built before
Right.
that. So that's a little bit of a wrinkle. But the good news is we've got the industry, the channel now has a year to sell through new systems.
Some of the things I heard about the component end of that. So if I walk into a supplier in February of 2025 and I buy a condenser, a 410A as a component, what's to stop technicians from installing these as new systems? So some of the things that I've heard are, well, a lot of these may come dry charged because of the scarcity of the HFCs. The warranty would be a component warranty and not a new system warranty.
Yeah.
So instead of getting a 5 or a 10-year, you might get a 1-year, those sorts of. So there's a lot of reasons to not go around the law and try and still install these as new systems because there's going to be a lot of wrinkles moving forward.
Well, the least of which, we talked that number one component of the AIM Act was the less availability of 410A and 134A, right? So the price, we're down 40% of a baseline as of January 1st.
Yes.
So that availability of HFCs like 410A, 134A is down 40%. And you know what happens when the supply goes down, what happens to the price?
Goes up, right? A lot of us are saying, well, I don't see it right now. I walked into my supply. Well, it's minus 10 outside, so you're not going to see a huge demand for 410A right now, maybe in refrigeration. However, once it hits 90 in Chicago, it'll be 120 in Texas and Arizona, you're going to see demand spike and go through the roof, and they're going to have to temper that to try and keep their supplies, and you're going to see the price go up.
Well, and the need to fill that gap, right, would be
Reclamation.
Reclamation, the recovery of the dirty gas, right, is the prerequisite.
So we've been preaching this for a long time. In reclamation, contractors, when they go to a job site and see this system is still charged, I'm going to replace it, there's 410A in the line, you have to stop seeing that as an inconvenience and start seeing it as a commodity, as a revenue stream, because there is money in recovering that 410A and getting it to a reclaimer. They will buy it back, especially if it's good, clean 410A. So if you're servicing multifamily or large systems where you have hundreds of pounds of 410A, again, reclaiming that as a commodity to sell to the reclaimer is a revenue stream for the contractors. And it also ensures that we have quantity moving forward, because the AIM Act, the phase down that Chris brought up, the 40%, doesn't apply to reclaim. If we bring in 100 million pounds of reclaim, we can put that 100 million pounds back on the market.
Right.
That just means it's staying in the refrigerant economy. It's not getting out, it's not being released, it's not having an environmental impact.
Yeah, and here's the big difference between this transition and the last one we went through in 2010. We went from R22 to 410A. Right. There were, let's call them for all intensive purposes, drop-ins for R22. Mm-hmm. There is no such thing. There's no drop-in for 410A.
Right. I think there's 17 SNAP-approved replacements for R22.
Right.
There are 0 SNAP-approved replacements for 410A in any application at the moment.
Yeah, we as an OEM producer, we had to go through and approve those alternatives for R22, for equipment that was still under warranty. For 410A, there is no Class A1 below 700 alternative. Now, I think people will point out, hey, Chris, there's some stuff being advertised.
I saw it, yeah.
Right? As
it's
a drop-in.
Snap approved.
It's not SNAP approved, but even if it were, it's not below the 700.
Right, I believe it was like 900 or something.
Yeah, depending on which AR value, 900 to 1,000. So it's still above that 700.
And then the other problem with that is none of the manufacturers have said, you can use this in our equipment. It hasn't been tested by the manufacturers.
Yeah, and of course, as an OEM that uses other people's compressors, we would go right back to those suppliers and say, hey, are you going to honor the warranty?
Right.
Right, which is what we did with the old, when we went to 22. So the point is, there's no get-out-of-jail card here with drop-ins.
In 410.
In 410, right now. There's some other fluids that we're transitioning for other sectors that have some options.
Right.
In refrigeration that are non-flammable and lower GWP. But for the bulk, residential, like commercial, there's no...
In the comfort cooling sector especially.
There's no replacement. Other than the reclaim is the key.
Right. The only thing that can go into a 410A system is 410A. And we've had some comments come up, well, 410A is a blend of 2 refrigerants, R32 and 125. And 125 is more of like a flame suppressant. It's put in there to bring the classification down from 2L to A1. Some folks say, well, if 50% of 410A is 32, can't I just put 32 in my 410 unit?
No.
Temperatures and pressures are close, right?
Yeah.
No,
you can't. And when we did the research, when we first started looking at which fluid we would use in which products, right? And we sell all the products. We took some native 410A equipment, residential splits, some rooftops, pulled all the native 410A out, put 454B in some, put 32 in some. One, you can't do that, so that was by
it's
codes.
a SNAP violation, right?
It's a SNAP violation, and it's a UL violation as well. 60335-2-40 doesn't allow for mixing of those, because that fluid, you have to certify the equipment for which the fluid's being used. But here's what happened. Because of the pressure temperature differences, the compressors failed in the 32.
Yeah.
Because of the oil viscosity, higher discharge. Now, 32 is a good fluid, 454 is a good fluid when the equipment's designed
for it, right. You can put it in spec. So the other thing about this is these 410A units don't have any mitigation in place that the systems coming out with 32 and 454B are required to have by 2-40.
Right.
You have to have mitigation to pick up on a leak, shut the system down, establish airflow or ventilation.
That's right.
Our existing 410A systems don't have any of that. So you're creating a very hazardous
because of the
situation.
flammability difference.
Right, yeah. So by trying to take a flammable refrigerant, a 2L mildly flammable refrigerant, and put it into a system that was not designed to use it, you do create a hazardous situation for your customer.
Right, and when you look at the they call them RDS, refrigerant detection systems. Yes. Every 2L system, unless it's below a certain threshold, and like depending on the fluid,
3.9 or 4 pounds, something like that, yeah.
And it varies a little whether it's 32 or 454B. But if you're above that minimum threshold, they call it M1.
Right, M1.
Every application will be designed to accommodate an RDS, but not every application will require.
Right.
So if you take this building as an example, right? She had a large rooftop that leaked out 10 pounds of 454 or 32. Guess how much space here? There's not enough concentration.
You wouldn't even notice it.
Well, they wouldn't be able to build up to what we call the lower flammability limit. So if you did the math between what they call the releasable charge and the space,
volume, right.
an RDS wouldn't be required.
Fuel, I mean, we need three things for combustion. We need the fuel, we need an ignition source, and then we need air. If we were to leak, like you said, 10 pounds in here, we would have way too much air and not enough fuel, and then we would still have to have some sort of competent ignition source, like a cigarette lighter or a torch or something.
Right.
Static is not going to do it for these 2L refrigerants. So they do have high LFLs, they do have high ignition energies, they have a very low heat of combustion when compared to propane or butane, those sorts of things. So it's not the sky is falling that a lot of people are making it out to be. We do need to realize that the 2L refrigerants and the 3s and the A1 does not stand for non-flammable. It means no flame propagation under a specific set of circumstances. 410A is an A1 refrigerant, but if you have a structure fire, a house fire, that 410A burns really good. I've seen it.
Yeah, and I would encourage your listeners, you and Clifton have put together a nice video. If you haven't seen, your listeners haven't seen the video, I encourage them to go watch it.
It's on the ESCO YouTube page, yes, and I believe you have it as well.
We've linked it as well because we like the video so well. That goes through A1, A2, A3.
A2L, A3, right.
Yeah, it's a great video, and I think it really demonstrates the differences between those flammability classifications.
And there's a specific set of circumstances for any refrigerant to become flammable. As you mentioned, the 2Ls are way closer to the A1s than they are to the A3s, the propane and the isobutane.
Right.
Not to say that we're not going to use those. Those are going to be a big part of the equation moving forward. SNAP 26 bumped the limits for propane up, 350 and 500 for open and closed, so we're going to see a lot more of that moving forward.
Yeah, I want to emphasize something on the A3s like R290 propane and so forth, isobutane. In the U.S., our housing stock is predominantly air-to-air, so we have refrigerant in the space.
Right.
Some of the other countries like Europe, they use air-to-water systems for a lot of their residential.
Right.
And so their refrigerant stays outside, and then they have a secondary loop.
Glycol or something like that.
That goes in the home.
Like a mini chiller.
That's where you can apply an A3 like propane. Right now, the 150-gram limit set in the standards will really inhibit an A3 from being used in what we call a direct system like that.
But that's an indirect system, what you would just
That's an indirect system.
We can see maybe 5 or 10 pounds in an indirect system where the propane is completely contained outside in the package, and then we have a secondary fluid transferring the heat, where the A3 never enters the space, as you mentioned. We can see a lot larger charges in those, and they're already out in Europe. I've seen them. I've talked to the manufacturers. There's some that use 5 and 6 pounds of 290. Again, in the primary loop, and the secondary loop is a glycol-based, non-toxic that transfers the heat, and they work just fine.
Yeah, and the thing I'll point out, there are, in conjunction every year with the expo, there's the ASHRAE meetings. There's committee work going on in ASHRAE 15.15.2 to look at these indirect systems, because even though the propane, R290 or ammonia, whatever it might be, is outside, there's still going to be clearance and issues that you can't just put one of these outdoor units anywhere, right? So if there's a leak, an egress on a rooftop.
I was part of the NFPA study for that 15.2 is using, and what they look at is, the window wells, where we have the covers, the windows are underground, stairwells going down, leaky window structures. Again, a lot of homes become negatively pressured and will suck in from the outside. If you have, and again, we know that if it's not windy out, propane is heavier and will collect in a low place until something comes along to either ignite it or move it. So like you said, we're going to have to look at placement. Where is it, by a door or a window, under a deck, near, So there will be requirements that say, listen, you have to find a space that's suitable for this application. It's not just a plug and play.
And, I think that one of the main points is we get asked a lot, well, when might the U.S. transition to A3s? And the precursor to that is the building codes, and I should say the safety standards, and then the building codes. And you look at the cycle where it took us to update for 2Ls.
It's like a decade.
It was a decade. A3s, if they were in a high probability system like we have today, I don't know that would ever happen. At least it would be kept to small charges, small tonnages. But the question really would be, do we transition to more of an air-to-water market like that of Europe? That's really where the question comes in.
So there are a lot of questions about what are we going to see moving forward. And again, what slows the process is, like you said, we have to do the UL standards for design, we have to do the ASHRAE standards for installation safety maintenance, and then they feed into the building codes and get adopted by the states. So it's a process that can take, like you mentioned, like a decade to get, and it's taken us that long with the 2Ls. When we were transitioning to 410A here in the U.S., Europe and them they were transitioning to R32, but our building codes were not so that we could use R32 in all of those applications. So they took R32 and they put a flame suppressant in there until it became an A1, and that was 410A. That's what 125 is. But 125 is an extremely high GWP. So 410A is on the chopping block.
That's right.
And then the other, some of the other newer next-gen refrigerations that you and I were speaking of earlier was CO2. We're starting to see expanded markets for CO2, mostly commercial, industrial applications.
Right.
In those markets, it is a really good refrigerant. With a GWP of 1, it's the baseline for everything.
Right.
And then, as we mentioned earlier, ammonia, again, is a 2L. A lot of folks don't know that ammonia is a 2L refrigerant. It is flammable.
It's also toxic.
Right,
it
just becomes toxic before it's
Yeah.
flammable. When you think ammonia, the first thing you think of is, oh my God, that stinks. Because the toxicity is present first. It becomes acute, but it is also a 2L refrigerant. So those of you working with ammonia already know about 2Ls. You just may not have realized it.
Correct. And, it's a good refrigerant, and any refrigerant, has to be properly applied, specific for the application. The question is, how far down, if you want to call it down towards the residential smaller market, will these naturals go? And I would say, again, not one size fits all.
Right.
It's going to be sector by sector, different dates.
It's going to be a group of refrigerants that make up this next generation. A2Ls like 32454B, A3s like isobutane and propane, naturals like ammonia and CO2. So moving forward in different sectors, we're going to see a lot of different next generation refrigerants, which brings me to the training side of it. We're going to start, as technicians, as contractors, seeing refrigerants come into whatever sector we're working in that we haven't used before, that we may not be familiar with, and they're going to be different from the refrigerants that we've been using. It's not your father's refrigerant, as they say. All right? So we're talking about training and what should we do. We take somebody that's working with 134A systems, or let's just use 134A and say, listen, you're going to be using CO2 now. All right, well, that's a whole different skill set right there as far as recovery, gauges, installation, maintenance, detectors, all of these things. There's a lot to learn there. We can't just assume that this person is going to just, I'll go on Google and I will look up CO2, and, after some time in the bathroom on the toilet reading my cell phone, I know how to use CO2. All right, I'm not going to be confident that that's going to work. We're going to have some sort of something established, a training program that says, listen, if you're working with these, here's the information. And you got to, as I say, Google responsibly, all right? When you Google, the first one you see is the guy that paid to be the first one you see. It may not be the best one you see.
Yeah, some of these pressures and temperatures are going to look very different, and that's why the training is very important.
We're going to see different oils. We're going to see different transportation. Are you shipping it, in bulk? Are you putting it in your service vehicle? Where are you storing it? How are you storing it? What is it next to? There's going to be a lot of things that we're, as an industry, we're going to have to be aware of. And these things are happening fast. These deadlines are fast approaching. We just passed one, January 1, 2024, for the additional 30% reduction. Right. We got one coming up January 1, 2025. And then we have markers all the way to 2028, knocking off different sectors with the technology transition. So we have a lot of education to do. We have a lot of folks to train, and we have a short time to do it. Fortunately, there are a lot of people, a lot of organizations that have training available. You have your OEMs, you have ACA, ESCO, JCI has a training program. So what I would tell you to do is, listen, you have to go get this training. This is important. I was at the UL testing when they were burning the houses down and doing all the flammability testing. I've seen what it could look like, and we don't want it to look like that. So I'm encouraging training. It may become mandatory. I think Europe is going that route. In the future, they're going to require training on the naturals and the flammables moving forward, and it may be something we see here as well.
Yeah, I think ultimately there will be some changes to the requirements on the licensing side, but I would encourage folks not to wait until something's mandatory.
Right, I would, because then the line's going to be long and it's too late. We're going to start seeing this equipment, this 2L equipment, this year.
Oh, in a few
Probably,
months.
Yeah, like some
Months,
spring,
yeah.
summer of this year, when you walk into the supply house, you're going to see these refrigerant tanks, you're going to see these systems, and when you go to pick it up, you're going to see that little flame thing on the side, and you're like, wait, it says warning, and that's not what I ordered. Oh, but it is what you ordered. It's just what it looks like now. And you're going to have to prepare your customers to, when you walk into there and they see that flame and that warning, you better have an explanation ready for your customer. Like, just stand back, it'll explode. You can't say that. You never say the E word in the customer's home.
Yeah, I think, education for the consumer is
back
key.
end, right.
It's so important because, when the consumer first hears, what, my refrigerants are flammable?
Yes.
You need to be prepared for that. And there's a lot of resources out there. You guys have some, we have some, HRI has some, education.
has some,
is-
Hardy has some,
Hardy, ACA, and that's something I think we don't want to be surprised with, right?
Right. So like we mentioned, there's A3s in the refrigerator freezer in your house. There's an A2L in your car. A lot of people don't realize what that means. Well, there's propane in your refrigerator. Well, I didn't buy it at the store. There's no propane in my fridge. It came with the fridge. It's inside the fridge. There's an A2L in your car. I don't know what that means. It makes your AC work. Good. But they don't know that it's an A2L and what an A2L is. We as technicians that work in heat transfer thermodynamics, we know what A2L, we're going to know what A2L is, what a natural is, what GWP is. These are all terms that we have to add to our vocabulary. And then we're going to have to develop an explanation that we use to bring it down even further to that customer level, because the end user is also going to have to know what this means.
Exactly. One of the things we're encouraging through our channel partners is proactive outreach.
Right.
And, with the phase down, if they've got older equipment, it's an opportunity to do, an inspection. That's an opportunity to do some communication. And, it's also an opportunity. They may want to bank some of the refrigerants if their equipment's not near the end of their life.
Right.
And hold that at a lower price.
A life study.
Yeah. So while there's regulation change, not always fun, it does create opportunities for
It does.
channel partners. So.
And one of there was two main comments that we get when we're doing training. One is, it's propane based. Okay, it is not propane based. None of these 2Ls are
No
propane.
hydrocarbons,
Yes.
yeah.
Okay, let's start with that. And the other one is, my customer's not asking for 2L refrigerants. Well, when you bought a car, you didn't ask for a car with a 2L refrigerant in it. It just came that way, right? That's how they come now. All right, these systems, that's how they're going to come now. We're not going to have a menu to order. Let me get that evaporator, that condenser. It's not like that. This is what the industry is transitioning to. And just because your customers aren't asking for it doesn't mean you can't be on the proactive side. Say, listen, I'm doing a cleaning on your system this year, but I will let you know we're near the end of the life cycle, and here's what the future of this is going to look like. All right, the refrigerants are going to be different. There's a different set of regulations and things that govern the use of it. We just want to make you aware of that. Again, it doesn't hurt to inform the customer that change is coming. At least they won't be shocked by it when they see that big sticker on the side that says flammable. They're like, what are you putting in my house?
Yeah, and just understanding the basic kind of physics of why is it flammable? Well, we want lower GWP.
Right. It's
Those substances will break down, and when they break down, that means basically they're more reactive. So it's like a lot of things in the engineering world. There's trade-offs. Outside air, right? We want
Right.
more outside air, but guess what? It uses more energy to heat or cool that
Bringing in
outside
fresh
air
air,
rather than
yeah.
you're bringing it. So this is no different. It's a trade-off, and everything's a balance when you design these products.
Right. So for a lot of the folks that are asking, well, okay, what is GWP? All right, it stands for global warming potential. And the baseline that we use is CO2, which has a GWP of 1. So if I tell you that 410A has a GWP of 2,088, everyone's like, all right, what is 2,088 what? Dollars? Cents? So what that means is the ability to trap heat in the atmosphere, that our 410A can trap 2,088 times as much heat as CO2 by itself. All right, that's exponentially, massive, all right? So when we talk about the GWP limits, residential like commercial, the target as of now is 700 GWP, and that knocks out almost everything we're using today.
Right.
410A, 404A is like 3,900 something. 410A is 2,088. So these are high GWP refrigerants. They trap massive amounts of heat when compared to CO2. When we talk about CO2, ammonia, propane, isobutane, these are like 1, 2, 3. Even YF is like 4 or less. In some reports, less than 1. So these are the next generation refrigerants that we're going to be looking at. When we started, as you brought up the Montreal Protocol,
Right.
it was the chlorine, the ozone depletion potential, and now we're at the GWP. And again, we're moving these things down based on their effect on the environment around us. As you said, it's a trade-off.
Yeah, it's a trade-off. Yeah, and I think, if you look at where we're headed, you've mentioned naturals and so forth. Again, it's going to be a sector by sector, equipment type, if you want to say that by equipment type going
Right.
forward. There'll be different solutions. And what that really means for your listeners, I think, Jason, is they're going to really have to get good at refrigerant management.
Right.
Understanding refrigerants, everything about them, storage,
Transportation,
service practice, right?
Safe
Oils,
handling.
evacuation. And that's just the day we live in. But if you look at the other sectors, refrigeration, applied, they've been doing that for years.
Right.
That's not new to those sectors. So we are ultimately going to head that way. And I would say it creates a lot of business opportunities out there. It could be a win-win. The customer,
If it's done right, yeah.
done right with higher efficiency, well-maintained equipment that's safe and reliable, just like we have before. It's just different, right?
So if you're a company, contractor, equipment manufacturer, and you span a few of these equipment types or sectors, if you will, if you do refrigeration, commercial, residential, you're going to see a wide variety of refrigerants moving forward. You might see CO2 in this application, propane in this application, YF, 1, 2, 3, 4 YF here, R32 here. Again, depending on the types of equipment that you work on, what does your company service, you're going to see a lot of, whereas right now we're dealing with HFCs. It's an HFC in almost everything. Well, moving forward, it's not going to be that way. It's going to be a group of refrigerants that make up what we call the next generation of refrigerants. And each one is going to have something specific that you need to know about it, whether it's high pressure, whether it's flammability or toxicity. We're going to have to understand the nuances of each of these refrigerants moving forward.
Yeah, one thing I want to say, too, about our equipment, this generically applies to, a lot of the OEMs. As we evolve these designs, things like energy efficiency, we can't forget about that.
Right.
Pretty important. And from a training perspective, if you look at some of our newer technologies, they're using less and less refrigerant.
Right.
What's a good thing is it's flammable. But what it means is to charge that product accurately, your equipment has to be really good. So what I'm encouraging the contractors to do is to use this transition as an opportunity to upgrade your training, upgrade your equipment.
Yeah.
So you can charge, and I can tell you, our premium systems, particularly residential, a few ounces of charge off makes a big difference
Right.
in efficiency and performance.
So bringing that up, if you're using an analog gauge, it has a plus or minus of a certain, like they call it a 323 gauge, 3%, 2%, 3%. You can be off by 20 psi, which can equate to multiple degrees. So if I specify a 10 degree superheat, you could be within 5 to 7 degrees of that. Some of this newer high-end equipment specifies a superheat of 5.8 degrees. All right, well, how are you going to do that with an analog gauge and just weird thermistor temperature probe? You're not going to get 5.8. But as you said, just a few ounces, and it's all of a sudden it's outside of its normal operating parameters.
Right. I mean, we go to great lengths to, provide as much training and information we can to have that charge, specifically specified. But if it's not put into that level, the days of plus or minus 10, 15%.
Yeah, right.
That doesn't work. You're not going to get optimal performance out of particularly a high efficiency machine.
High performance system,
Yeah.
right. I've seen systems here that as we're walking around with A2L refrigerants, 2.5 ton heat pump, factory charged with like 2.5 pounds of refrigerant, and the full load amps are like 0.5.
Yeah.
All right. I can't imagine a 2.5 ton system in the field that draws 0.5 FLA charged with 2.5 pounds of refrigerant, all right? But that's where we're at. We're with inverters, SEER2, high efficiency. These fluids that we're talking about, better thermal efficiencies, better circulation, more control.
Yeah, and I'll mention, this tying a few trends together with the transition to more heat pumps in colder climates.
Right.
Getting that charge correct, and really the key thing in cold climates is not overcharging,
Right.
is super important to the reliability and performance of cold climate, when you're running a heat pump.
So you're going to charge it in the summertime when it's in cooling mode, and if you don't do it just right, when the weather drops to 15, it's not going to heat properly. And then how are you you're going to be out in the snow trying to charge this heat pump properly.
Exactly.
So it's critical to do it when we're doing an installation. When I say the word commission, we think of industrial or commercial applications, but residential installations, it's gonna have to become a commissioning thing where we're doing it properly the first time, each time, so that we can ensure operation across a variety of temperature applications, depending on what the weather is. For like specifically heat pumps.
And we all know it's expensive to revisit a job.
It is.
And so trying to do that right the first time requires the training, proper equipment, right, to do that.
Right, tools,
Avoid
training.
that follow-up call to get it done right. So.
You can't just walk in and do like for like anymore. That's just not going to cut it.
Yeah.
We've seen some sessions here about home performance and sealing the home and being able, again, if you're taking out a gas furnace that has a discharge temperature, say 120 degrees, you're not going to get that with a heat pump, all right? So you have to temper the homeowner's expectations. Listen, this is going to operate a little different from your gas furnace.
Yeah.
All right? I mean, you're going to see maybe 90, 95 degrees coming out of there, not the 120 or 130 that you're used to. Because they're going to call and say, listen, it's blowing cold air. Well, it's not cold. I mean, it's 95 degrees. You know what I mean? It might feel a little colder, but it's not really cold. It's heating the house.
But your body temperature is 98.
Right, so it feels cool to you, but it is heating the home. Mark my words. So we've seen the energy efficiency take off, the SEER 2, depending on what climate zone you live in. We've now seen the transition to next-gen lower GWP refrigerants. Some are natural, some are flammable. There's a lot of change in the industry. There's a lot of change with equipment. And we're going to, again, moving forward, we're going to be as good as our training and our tools. We can't just do the same old like my dad did, all right? We're going to have to take that next step and be better than that.
Well, and as you know, a lot of the training is now, there's a lot more electronics, right?
Right.
Not to say that, pressure and temperature don't matter in analog, but
Superheat is still superheat, though.
all your troubleshooting, diagnostics, communication protocols, right?
Right.
Thermostats, automation.
Inverters.
Digitalization, right? All that. The training is just, paramount to happen these days.
So we did see, things like this coming. Other industries, their technology upgraded faster than ours. We stood still for quite a long time, and now all of a sudden the dam has broken. Everything is coming out. We're seeing all of these new technologies, these new refrigerants, all of these new tools, all of this training. It's an exciting time, definitely, to be involved in this. And again, this is going to span to, say, 2050, where we're installing billions of units. I mean, there's going to be work forever. All right, this is a very good opportunity, again, at the time that we're in, to be in this trade. You just need to arm yourself, be prepared to work with the tools and the equipment and the refrigerants and the things that we're seeing today.
Yep, we put in 9 million new residential commercial units last year.
9 million.
9 million just new, right? It
Right.
could be new construction or replacement, but that's a big number, and it's probably going to grow.
Huge number.
Yeah. So our industry is going to stay essential even through COVID.
Right.
Our future ones. We'll continue to work, and we're going to have the kind of challenges, I would say they're good challenges.
They
with
are.
volume of work, opportunity.
Especially if they say the planet's warming, cooling is going to become more important than ever right now.
Energy efficiency.
Right, energy. We can't keep generating massive amounts of heat to cool the house and then release that heat and not think we're going to create a problem. We're going to have these energy efficient systems and fluids in order to accomplish this.
Correct. That's right.
So moving from, again, like you mentioned, next generation refrigerants, we're seeing the push for cold climate heat pumps. In areas like Chicago, there's a lot of folks in Chicago right now installing heat pumps. It was minus 35 if you were here last week, and the heat pumps were running just fine. They were able to keep up. So it can be done, but it has to be done right. We have to have the training. We have to have the tools. We have to have the knowledge of what to anticipate. And again, that comes from sitting down and taking a class, learning how to do this from your OEM, from different organizations. There's a lot of training out there. But it can be done. It's not something that's impossible or just won't work just because you don't want it to work. There's my saying on this for a lot of folks is, how can you install a heat pump in Chicago? Listen, a heat pump is an AC unit that just got curious.
I hadn't heard that, Jason.
Yeah, that's my little saying, yeah. And so for the record, I will say that all of this transition that we're experiencing, Chris and I had nothing to do with this, all right? We were just witnesses. We were there. We heard what was going on, and we're bringing that word to you. We didn't sign anything. We didn't pass anything or vote on anything, all right? This came from the upper levels and came down to us, and we're passing it on to you. We're kind of like a go-between, if you will, between the legalese, where it's 1,600 pages of legal documents, and then we turn it into an hour-long podcast to let you know what all that says.
Yeah, I think for us, we just want our channel partners to be successful, right? We want to have a good quality product delivered on time, operate, the consumer's happy, and that takes training.
It does. As an OEM, you can't put your equipment out there and then someone take it and put it in and it doesn't perform, and then the homeowner blames your equipment and not the technician. Oh, that unit stinks. We can't. Don't use that unit. All right, we can't have that. The OEMs have spent a long time building up this reputation for making quality, reliable, efficient equipment, and in order for that equipment to be quality, reliable, efficient, the installing technician and maintenance technician are going to have that training in order to keep it that way. All right, we can't have mad homeowners and mad OEMs because things aren't being done properly. It's going to tear the industry apart. So we have to bring everybody together and do the training and the the updates, if you will, to make sure that this is being done properly, so that everybody's happy.
Happy consumers is what we want.
And technicians, too.
Yeah.
So I think that's about all the time. Are there any questions before we call it a day? Are we good? I think we covered everything in the next gens, right?
I think so.
Everything from flammable to natural, A1, A2L, A3, naturals. We're going to see them all moving forward. You'll see a lot of it this spring, this summer, and the equipment that's coming out and over the next 3 years. And again, depending on what you service and what you work on, you might see a huge library of refrigerants from industrial, commercial, to residential, to packages. You're going to see a wide variety of refrigerants moving forward.
Yep. I just finished closing by saying it's some urgency because the market's about to really, here in just a few months, really start seeing the influx of these new refrigerants, particularly residential.
Right, and the dates that we had spoke of, they're all coming. One just passed, January 1, 2024. Another one, January 1, 2025. And then a whole series of them between 2025 and 2028 for all of the different pieces of equipment. So the dominoes are going to start falling, and they're going to start falling really fast. The first one already fell.
Yeah, so hurry on the training.
Yes, don't wait till the last minute, or you're going to get stuck in the cold.
But don't wait till it shows up in your warehouse.
Until it's in the back of the truck and you're sitting at the customer's home trying to read the installation manual and figure out how to install this. Well, page 3 says we got to do that. Hey, get the thing out of the truck, the thing on page 3. That's not going to work.
Yeah, well, and what we're encouraging, Jason, is that for the first time an install occurs in your region, make sure you reach out to the local AHJ for the first one to make them familiar. That way there's no surprises. There's some resources online that were rolled out this week with HRI.
Yeah, the new map.
The new map that says by state what codes enable these larger charges of A2Ls. Brand new.
What was pointed out was some of it was done legislatively, which means that the code bodies may not know to what standard or to what I should be installing this to. Legally, can I do it? Yes. But for an AHJ, they may not know, all right, what am I referencing for this installation? So there's some communication between the installer and the inspector there to say, listen, let me help you out here. If you have the training, you'll know exactly what standards you're supposed to be referring to. You as the contractor, and you can. And then it's always good to make friends with the inspector. All right, bring them a coffee and say, listen, here's the standards. I'm installing this unit. Like you said, the first few, once they get the hang of it, then it'll be a breeze. Hopefully, being done properly.
Yeah, and I think it's important in those states, and the HJs know which one they are. Their building cycles on adopting these national model codes can be quite long.
Yes,
so in those cases where the state update cycle didn't align with the EPA dates, knowing what legislation enabled that is even more important. And that's why some of these HJs just may not be aware of it. It's not the right time.
And it was done way above their head and without their knowledge.
Correct.
So like he said, there's a lot of resources out there, the AHRI website, the ESCO website, the JCI website. There is a lot of training that is available. There's a lot of resources. If you walk in your travels today at the show, pay attention to what's in some of them heat pumps and some of them commercial, industrial AC units. You're going to see a lot of 2Ls, a lot of naturals, a lot of these next-gen refrigerants.
Yeah, I just encourage you, don't, embrace it. It's coming.
Right.
Be ready for it. And it's a great business opportunity.
It is. The saying is, the change train is coming through and you have two options. You can stand in front of it and get run over, or you can get on it. All right? It's more comfortable on the train than in front of the train.
Yeah.
Train. All right. We're going to call our show. We'll thank everyone for sitting down and listening, and we'll be here throughout the day if you want to stop by our booths, JCI, ESCO, and say hi.
Thanks, Jason.
Thank you.
Okay.